Good morning, all. Am I audible to everybody? It's great. Great. Yeah, I'm seeing a lot of school children there, and happy to see you all. Good morning. So today we are going to have a session on Arduino. So let me introduce myself. So I'm Rajesh Kushalkar. I'm heading the open source hardware under the FOSSEE project, a mission by Ministry of Education under NMEICT. So we are here to tell you about what is Arduino, what all Arduino can do for your,
Excuse me, sir.
how it can help you to
Excuse me,
learn
sir.
programming.
Excuse me, sir. Have you
Yes,
shared any screen or something else? You are sharing
yeah,
something?
yeah, screen. Acha, I have to
Ah,
share the screen. No,
yeah,
sorry,
yeah.
sorry, sorry, sorry. So the screen is visible.
Yes, sir.
Yeah, thank you, Deep. So good morning, all. I'm Rajesh Kushalkar. I'm heading the open source hardware division under the FOSSEE. And today here we are going to look into the Arduino. The topic of this particular session is Arduino from curiosity to innovation, build, learn, and invent. The topic why it is given, because you have to build something, you have to code something, you will be there will be a learning process in it, and you are going to invent something out of it. So because there is always a before invention, there is always this process of build and learn. So as a child, you must be knowing that you must have gone through whatever gadget you must have got it. For example, a toy car, even you take a pen or a ball pen. Whenever you have received, first you will just try to see how it is writing. Then you will try to open it and see how to refill it, how to fill up the ink or something like that. Suppose a toy car is there. Very first thing, what do you see? How to put up a battery, that how to see it. Once you get bit bored or something like that with a toy car or something like that, then you try to see how to open it. After opening it, you see, yeah, this is how the motor is connected to the gears, and this is how the wheels are rotating and all this thing. So this is something called as curiosity in your child's mind that keeps you always awake, that how the thing works, because that curiosity is always there. So everybody, every child, it's not that nobody likes to open the gadget. You would like to build a robot also, yeah, definitely you can build a robot, you can build a drone or a flying car or whatever you want to say, and tomorrow you can invent some new technology. So everything starts with that curiosity. So very first thing is you should have something in the spark in your mind that ignites that feature. Yeah, no, I have to the how this thing works, because it always happens that whenever you are trying to open a car, for example, so you see motor is there. So how does the motor move? So how does the motor moves? So if you just give a battery connection, you just battery connection given, that motor starts. But how, what happens inside? The moment I give the battery connection, what happens inside? Why the motor is moving? Okay, so that curiosity is always should be there among the kid to learn new things. Okay, so how the remote control works? I've talked about motors. Now how the remote controls work wirelessly, how the thing works. So you have seen the remote control of your TV gadgets or any other thing. If I just try to increase the volume or change the channel, it changes. But how it changes automatically? Okay, so that curiosity should be there. You talk at, yeah, it is infrared, this new terms and all this thing, you must have learned it. It is remote controls works on infrared. But what exactly infrared? But there are 40 keys on your remote control. How each key denotes that particular function and it operates. So you have to see all that thing in your curiosity. because this builds up the curiosity how the thing works. That is very, very important. So basically for electronics and Arduino, so we see electronics is a process where you start with your Ohm's law, very first thing, of basic electricity. Then you go on further to learn more of the things for the programming. Then they are building some robots or any other things. It's I'm not talking only robots, but there are a lot of things that can be done using Arduino. Now, what is Arduino? So Arduino is a small programmable electronic brain, or it's a very palm size controller, okay, board, which teaches, it has got various IOs on it. IOs is, we call it as input output. Okay, I/O, it is called as input output. Now what happens where in the input and output, there is something given to the input, like what we call as read some sensors, control a motor. Okay, now read some sensor. What do you mean by sensor? What do you mean by a sensor? So what are the senses what we have? In our body, we have got 5 senses. Okay, one is your eyes, through which we can see. Okay, second one is your nose, where you can smell. Okay, then you have a tongue where you can taste something. You have got an ear through which you can hear something. Okay, and there is a hand, touch. So that is a sensor. For example, you're touching some vessel which is hot. Now, the moment you touch your hand, immediately you drag your hand from that part. So means what? It is hot. What it is sensing? Your hand is sensing with a touch that something is hot, because hot, how it is sensing? The signal bends to your brain. The brain says this is hot, you remove your hand. So you see what is Arduino? It is a small electronic brain which takes the input. Now my plate is hot, or whatever is the hot, cup is hot. Immediately it tells the brain replies, you remove your hand from there. Okay? So you got a very basic thing of what is sense and what is the output of it. So what is sense? Again, I am telling you, I am touching a cup which is hot. So I am touching with my hand. The moment I touch, the signal goes to your brain. It says that it is hot. And what is reflects back? Remove your hand from there. Okay, it is too hot. So what is the output? Removing your hand is the output. Again, you must have seen, see there is something new dish or something which is getting prepared in your kitchen. You smell it. Wow, it is tasting so good. What is the output? Your mouth becomes watery. Okay, so this is how your brain systems and of your body sensing things works. Now, the same way, Arduino also has got some sensors or something as an input. Okay, then the brain, the Arduino has got a controller which is the brain of the system. It takes that input and define the output. Now, so thing is there, what has to be done? Okay, for example, here there is a sensor Arduino action. Now, example what I am giving here is temperature says Arduino turn on the fan. Now, there is a sensor called as temperature sensor. Okay, like your hand has touches, there's a sensor. So there is a small sensors, which are many sensors which are available, which is called as in Arduino or any other thing. There are different kind of sensors. You have got touch sensor. You have got what your mobile phone is. There is your touch sensor. So you can touch your screen and you can move your up and down screen. You can do it. There's a touch sensors. So like that, there's a temperature sensor. So temperature sensor, as the name says, it senses the temperature. Now what happened? I can write a program for Arduino saying, if the temperature goes above 25 degrees Celsius, so the fan should turn on. So what is the output here? The turning on a fan is an output. But what is the input? Temperature is the input. Got it? So the moment the temperature is sensed, it goes above 25 degrees Celsius, the Arduino says that the fan should turn on. If the temperature goes below 25 degrees Celsius or something like that, then automatically the fan should be off. So hope you got the concept of temperature. What is the input and output for the Arduino? Hello? Just put up a thumbs up for your things so that I can see that you're able to understand what I'm saying. Great. Thanks. Thanks a lot for the feedback. Now, real life examples for how basically Arduino can build a smart irrigation. Smart irrigation, I'll give you a very small example. Irrigation is the farmers have got a very big farm and all this thing. But you can just consider your home. So you have to water your plants every day. Now, suppose your water, the pot or the plant say that I am thirsty. So that time only it will turn on the water and it will give the water. So this is a very small things of smart irrigation. Okay, very first thing. So there are something called as soil moisturizer sensor. So it senses your soil moisturizer, how much moisture is present in your soil. If there is sufficient, as you have programmed it, if is sufficient moisture is available, so it will not water the plant. The motor means output is what? Motor. The motor will turn on, it will pump the water to the plants. So this is something called as a smart irrigation, a very small thing. But smart irrigation also contains a lot of things like you consider what is the humidity of that area, what is the temperature of that area. So all this thing comes under the smart irrigation. Okay. Next is your robots. Everybody knows nowadays how the robots are controlled and how the artificial intelligence have coming into the robots, that it behaves like a human being also. So these are the small things which you as a student have to think how a robot is talking. If I'm giving you, for example, Alexa, I'm asking you, hello Alexa, what is the weather today? So it goes to the internet, it talks to you back or something like that. So how that is built? How Alexa, I can build an Alexa using Arduino also. That is possible. It's not like that I can't build that thing. That is also possible. Okay. But you have to program that way, in that particular fashion, and definitely you can achieve that thing. Then home. So then comes the home automation. The moment I come to, suppose, home, I say turn on the light, turn on the AC. So it turns off automatically. So this is how home automation is also there. Okay. Now I'll give you a simple example of a home. My home is connected to the internet. Okay. So with my phone, I'm saying the moment I reach home, my room temperature should be so and so. The AC should be turned on. Okay. So what my system is going to do at home, it is going to see my location where I am. So though it is going to say, okay, for 22 degrees Celsius, if I want to make my room available by that time, it takes me 15 minutes. Suppose it takes me 15 minutes to come to that particular temperature. Now, I'll just going to look into my path, okay, how much time I'm going to take to reach. The home is going to see my path. Yeah, now he is going to take half an hour. Now it is going to take 20 minutes. Now, the moment it comes 15 minutes, the AC will be turned on automatically. And the moment I reach home after 15 minutes, I will get that room at 22 degrees Celsius or whatever is there. So this is more like an home automation. Your home is going to come on the internet. So the moment all this smart gadgets, whatever I'm talking about, smart irrigation if you talk, home automation if you talk, weather station when you talk, or air quality whatever you talk, when it is connected to internet, this small devices, when it is connected to internet, what we call it as IoT, Internet of Things. Okay. Till now what happened? I was just having a temperature sensor which tells me the fan to turn on the fan. But suppose that small device is connected to internet. and from there only I will say ki, yeah, so and so thing has to be done, it will do that part. Okay. Same thing, home automation I have talked about. Weather station, it will continuously monitor your weather of your place, like temperature, humidity, and other air quality and all this thing. So why Arduino is popular? Because it's a small prototype board. It has got a small controller on it and various input output. We call it as I/O. So various input output pins on it, where you can connect various sensors, various input like LEDs, output like LEDs, buttons, and all these things that you can connect it. It is easy to learn. So a student can learn either using the block-based programming, like a Scratch programming, that we are going to demonstrate to you now also. And if a student is familiar with the programming or C programming, they can always do with the C programming also. It is one of the widest used worldwide product for prototyping. Many of the students first try to do it with prototyping with Arduino only. Once they design everything, they run everything, then they try to do it. But what we generally in today's world, what we say, first, before coming to make anything, first you have to see what is your idea. Suppose I have an idea that I should have something called as class attendance system. I want to automate the class attendance system. How I'm going to make it? Okay. So there is a way. So how you can do that thing? What is going to be affected? How it is going to be beneficial for the school or anything? You just have to think. Once you thought for your process, then you should go ahead and try to design something. Don't code. Never ever code first. First go to design, talk with the people, come out with a design. Then after the design is made, first always try to do in a simulator. That is what we are going to demonstrate to you. You really don't require any Arduino at your lab or anything. First you should always go with a simulator. Simulator will give you everything. How to add a component, how to connect a component, how to write a program. Once you written the program, you should simulate it and see the output. Once you see the output, then you know, yeah, this is how it is done. And once you're satisfied with your output and all this thing, then you can go for the actual designing of your circuit. So why learn Arduino? So what are you going to learn with these skills as coding, electronic design thinking, problem solving, and innovation. Okay. So what you are going to learn, very first thing is going to be, you're trying to, as I told, I want to automate my attendance system in my class. Okay. So you're trying to see there's some problem in it. Teacher, hello? Yeah. So there's some problem in it. So how I'm going to solve this particular problem? I've just given you a small example only. For example, automatic class attendance. So you are going to design things around it. Now for designing, yeah, I want to require some electronic part so that I can detect who is coming in and who is going out. Okay. Now once that is done, then you are going to, once the design part is, electronic part is done, then you have to write a code for it. Once the code is done, please remember that all this thing I'm talking in terms of simulation part only. Once you've done all this thing, simulation, everything is working for you, then you have made a product, you have deployed it somewhere. Now whatever you have deployed, now it is working properly. This is called something you have innovated. Okay, and many people are using it. So Arduino is widely used. Hello. Arduino is widely used by the robotic engineers, IoT developers, electronics engineers, AI hardware, and startups and founders. Okay. So careers, learning Arduino can lead to careers like robotics, IoT, space technologies, smart cities, agriculture technology, medical devices. So even if you see, medical devices and all these things are also having lot of application using Arduino. So how you must have seen the smartwatches, how the smartwatches talk you about what is your heartbeat, what's your blood pressure. Okay, so how it is measuring? There are some small. If you see at the back of the smartwatches, there is some two lights which are blinking. It is putting on your wrist and continuously testing your blood flow, and through that it is testing your heartbeat. Okay, so there are this is what I called it as a different sensors which helps you to detect various things like a heartbeat. If you say I can take a ECG, I can do lot of things with in the medical terms also. Agriculture, I have told a lot of things. Smart cities means what you're talking is automatic traffic light controls are there. Then smart city also thinks of talks about cleaning your nearby area. So many times it happens that all the garbage is full and nobody is coming to pick it up. You can have a smart garbage bin systems where it detects the garbage is full. It automatically tells the municipal people that so and so place the garbage is full. You have to come and collect it and all this stuff. So these are the various things that I'm talking that you can use or try to innovate some problem statements which are available, how you can solve it, and try to do the prototyping with the Arduino. Now there's something called as space technology also. Now Arduino has already gone in space also, where it goes to a certain altitude. Now, so it goes to a certain altitude, then it records the data of temperature at that particular altitude, what is the humidity, what is the UV rays, calculations, and all these things. So this all things, again, I am talking, these are everything is done with the help of a sensors. Okay. Now you must have seen today, many people are trying to do the drone flying and all this thing. Okay. Now if you are just consider your mobile device, a simple take a mobile device also, how your mobile device is trying to help it. Okay. Now you are watching a video in this particular form. The moment you turn your phone in this particular way, the video becomes long. So what is there in your mobile? There is some sensor which tells your mobile that it is tilted. Okay. Now this is this position, this is tilted. So though I have to shift my video or whatever is there, whatever you are seeing, the image or whatever is there. So your phone itself has got almost around 10 to 15 different kinds of sensor in it. Okay. So what are the sensors that you can see? The touch sensor. Okay. There are different buttons input. Here a camera. Okay. There's a temperature sensor. There's a GPS where you can find the location of your phone and all this thing. Okay. Then your tilt measurements, we call it as gyro sensors. These all things are available on your phone. Plus many more sensors are also available. Okay. So these are the various things that can help you out. Now, as I was talking about I/O, so I and O, which is called as input output. So what are inputs? Okay, so inputs are something that information is given to a system. For example, button, some sensors, microphone, I'm speaking, it is going in. Temperature sensor, some motion sensors. Now motion sensor, what exactly it is done? Suppose I'm walking in a corridor at night, or suppose at a night in your house, or I don't know where it is, but many times it happens street light, for example. So why you want to keep the street light continuously on and waste of power? Have some motion sensors attached to it. The moment it detects some motion is there, automatically the street light will turn on. Do you require all the time the street light should be on in the night? Okay, during the daytime it will be off. What it can be done? There is a simple sensor called as LDR which detects sunlights. The moment it detects sunlights, it takes, yeah, now sufficient sunlight is there, the light should be off. The moment it senses that it is not having that sufficient light, automatically that light turns on. Okay, so this is what we call it input. Now, what is the input? Here we are talking about motion sensor, LDR, temperature sensor. These are the various things as an input. So now button, the moment I press something, something is happening. So because the button is pressed, something has happened is the output. So should be something called as input. Now output is action performing by the system. So now LED, the moment I press the button, the LED should turn on. So input is button, LED is the action, it has to do, turn on. Now I have to define my program in that way. I'm writing a program for Arduino saying the moment I press the button, the LED should turn on. So this everything is written as a code for Arduino. Now same thing happens for the motor also. For example, you consider a motor overhead tank. Suppose I will just check it for my building or my place. There's a overhead, or my school overhead tank is there. So the moment it goes certain below level, the motor should turn on automatically and fill up the overhead tank with water. Now till now what happened, a person will go up and check, yeah, now this much is left, this much is left, water is left, and all this thing. After that he will go, yeah, now it has gone below the value, now I will turn on the motor. But there's a person is required to do all that work. But how we can automate that thing? There are sensors which are available which detects the height of your water level and all this thing. The moment the water level height decreases, I'll tell my motor automatically to turn on. So it will start pumping the water in my overhead tank. Okay. Display, whatever you see as an output is a display. Buzzer, if the temperature goes above this thing, the fan should turn on and it should buzzer also continuously. Like the thief alarm, burglar alarm and all this thing. It detects motion. Because at night, I know somewhere this place, if the motion is detected, so buzzer should turn on. Okay. So this is the various example of the input and output. Simple example that I've given. The moment the button is on, we write a program in Arduino saying that turn on the LED. Same thing for moisture sensor, turn on the water pump. So now we'll go with the demonstration for the Arduino, for which I'm just going to give it to my colleague Pratik, and he's going to demonstrate you with the electro blocks. Yeah. So before that, hope everybody has understood what I've gone through it. Any questions or anything, please feel free to ask. So now let's begin with the demonstration part, and you'll be really very excited to see how actually the Arduino works, and Pratik will demonstrate you the various things here. Okay, thank you. I'll join you back again after the demonstration is finished. Thank you.
Hello. Yes. Good morning, everyone. I hope English is okay because a majority of the schools preferred English language. So I will start with the session for the demonstration. So this is a website, Electroblogs. As sir mentioned that we prefer simulation part just because we don't want the young students, the young brains to do directly hardware part and hurt themselves. There is a chance of hurting themselves or damaging this hardware. So what we do is we ask the student to use the simulation platform. It is named electroblogs.org. I will just uh, send the link in the chat so that those who have the access to using a computer can directly use it. So I have shared the link in the chat. Yes. So on here you can see. So this simulation is basically block based. What you have to do is you don't have to worry about the circuit diagram, the connections. You just have to make sure that your logic is right. Whether when you want to turn on the LED, how much time do you want to turn on the LED? So that all aspect you have to control. The hardware part is taken care of itself. So here you can see there are blocks on the left side. So there are multiple blocks, logic level, loop blocks. Then there are variables which will come afterwards. These are the basic blocks for mathematical calculation in the code. And here we have sensors. So let's say digit display, fast LED, LCD screen, LED, go on to RGB LED, servo motor, and then we have analog digital sensors here. So let us just start with the basic Arduino program. We start with the LED blink, and I will just start from the scratch. So on this side, you can see there is a breadboard which is connected to the Arduino. There are no components here. So what you can do is you just have to find the LED block which is on the left side. You just have to click on it, and you will see there are two blocks available. So we want the LED block to be included in the blocks. So we will just drag it onto the center part, the palette. Yes, so you will see whichever block which are outside this loop block will be turned to gray. It won't be added into the circuit. As soon as we drag this block inside the loop block, you will see an LED connected to the Arduino via breadboard. Since you will see, I will just zoom in. So as you can see, the LED color is red, and you will see a red LED displayed here. If I change the color, we have the option of changing the color. Let's say if I change it to green, then the visual effect will also make sure that you will see a green LED here. We have, so Arduino have 13 pins for digital pins where we can connect the LED. So you will see from pin 2 to pin 13, we have option of choosing any pin which we are comfortable with. So let's say I choose pin number 8. So you will see there is a pin number 8 connected. And here also on the simultaneously you will see that the pin number changes here. I will just change it again. If I say I'm making it pin number 11, if we have an option of zooming in here, and you will see the pin number is changed to 11. So like that. So how does the logic works? So suppose we are creating a circuit where we want to blink an LED. So what does the blinking means? The blinking is basically turning on and turning off the LED at specific interval of time. So right now we have an LED block which is turned on, but we also need a block which will control the time. So we have a time block here. So when we click on it, you will see a wait block is available. Similarly, you can drag this out, create like just place it below it just to make sure that the logic continues, and we can change the time where we want the LED to be turned on. So let's say I'm making this 1 second. So what will this do? This will turn on the LED and it will turn on for 1 second. But we want the LED to be turned off as well. So what we will do is we will again go back to the LED block. Again bring this block here and place it below the weight block. So now we want the same LED to be turned off. But for that you have to make sure that the LED which you have turned on has the exact same parameters set for the LED which you want to be turned off. So here what we have, a green LED which is connected to pin 11. So here as well, what we will do is we will just make it 11, and you will see the extra LED which has come here. It will just vanish, and it will be turned to red. So both the LEDs are connected to the same pin, and when we change the LED color, both the colors are changed for the same block. So, and here we have an option of turning off the LED. So let's say we are choosing turning off the LED. So now what the logic is, the LED will turn on, the green LED which is connected to pin 11. It will wait for 1 second. That means it will turn on for 1 second and then it will turn off. But we also want the LED to be turned off for certain amount of time. So we are changing it to 1 second by adding a 1 second block. So the logic, what the logic is, the LED will be turned on. It will stay on for 1 second, then it will turn off and it will stay off for 1 second. So you will see this is a simulation screen, and we have a play button. So like any other simulation platform, when you play the simulation, the actual hardware, what is perceived to be a hardware output, it will be displayed here. So I will just play the simulation, and you will see the LED is turning off and turning on, and you will see loop 3 here. So what does the loop 3 means? Just for the simulation platform, we can control the amount of time the loop remains on. But when we go to the hardware, you will see when we upload the code, it will remain in the same state as long as we are connected to the Arduino. The moment we disconnect the Arduino, it will turn off. But when the Arduino is connected, it will run n number of times. So we can change the loop numbers here. So let's say I want to run the blink of LED for 5 times. So I will enter 5 and I will play the loop again. So you will see this is loop 1, loop 2, loop 3, and for every loop it will the LED will turn on and wait for 1 second and then turn off and wait for 1 second again. So this is regarding the output, what is visually possible. But suppose you are worried about the fact that what about the coding part? This is just the block based programming, where we are just dragging the blocks and connect it to the loop section. So here we have a code section as well. So as soon as you come here, you will see. So right now this is Python. I will just turn back to C code, the Arduino code. You will see the code is written here completely. So you don't have to worry about the code. Let's say I will just start from again. I will just dump this code here. Come back. You will see there are no LED connected here. I will come here. You will see. So this is the basic Arduino syntax, where in the setup block we write the code for the sensors which are connected to which pin. So suppose LED is connected to pin number 10. So that information will be given here. And in the void loop, what we write is what we want the sensor to do. So suppose we want the sensor to take reading and feed it to serial monitor, or we want to turn an LED on. So that part will come in the loop void loop section. So let's again generate a circuit with the same LED block. I'm dragging this block here, placing it here. So as soon as I place the block here, you will see the code is automatically generated here. So pin mode is out. So LED comes under the output sensors because it is giving the reading out. We are giving some information and it is displaying out. So suppose if I change the LED pin here, I change it to pin number 7. You will see a change happen here and here as well. We can do that for n number of time and it will still print the same, the whatever the updated pin number is. So let's, so I, so after that we have to bring the wait block. You will see here. So right now the setup part is done. We are just using the LED. So the setup part is done. Just focus on the void loop part. If I can increase the size, yeah. So just focus here in the void loop. I will just add this block. You will see a delay line is here. So this will, what this will do is, it will, whatever the state of the LED is, whatever this line of code is doing, it will stay on for 200 milliseconds. I can change the number, I can change it to 1, and you will see the delay has turned to 1000 milliseconds. Similarly, if I am bringing the here the next block of LED and changing it to 10 again, you will see this line of code has been added in the code. And again, for the wait block, to make sure that the LED remains off for 1 second, you will see the code has been added here. So the ElectroBlocks platform allows you to just use the block-based coding and not worry about the code, not worry about the hardware. But since you're learning for the first time, you can just use the block-based method and run the code. You can see the code is running. So suppose after this, you have done multiple number of times, you got a hang of all the simulation platform, what the hardware is, what the Arduino sensor is. So suppose you have a Arduino at your disposal and you want to write the code, like burn the code which has been given by the ElectroBlocks platform. So we have an option here. So you can see the IC option is here. I have, let me just check. Can we turn on this camera? मला आता सध्याला हेच पाहिजे. For right now, I want this screen. ते चालू आहे ना. So you can see when I click here, we get an option of uploading the code. You just click here. You will see. So right now I have connected the Arduino to my system, and that is the reason we can see a USB port. So if I just click on it and connect, it will go into a buffer mode. So what this will do is, whatever code the ElectroBlocks have given you for the blink of LED, it will upload it to the Arduino hardware, and it will show you a good job. Code has been uploaded message on the screen. So that makes sure that the code has been successfully uploaded. And so we have connected to pin number 10. So you can see the LED is blinking. It is turning on for 1 second and turning off for 1 second. So let's say I want to change the pattern. So I want to turn on the LED for 3 seconds, I can just change it in the wait block just below the on LED turn on block. I will make it 3 and I will make this as 0.5. So what this will do is the LED will turn on for 3 seconds and it will turn off for 0.5 seconds. I will just upload the code again using the same method and it will show me the message that the code has been uploaded. So now you can see the LED is turning on, staying on for 3 seconds. It is turning off for 0.5 seconds and again it is turning on. So as I mentioned in the hardware part, the process, the iterations will be infinite number of times. Just for the simulation part, we can control the number of turns that we want the simulation to play. So right now we have 5 numbers or times the simulation will play, but in the hardware part it will just turn, it will remain on for n number of times. So can I ask how many of you are using the actual? Yeah, I can see some of the students using the platform. You can just message in the chat like you are doing the simulation part, or if at all you have the hardware. I'm not sure if many schools will have the hardware available with them. Okay. Miss Anuradha Mittal, I think students from your batch is doing the simulations. Okay, nice. So just let me know when students are successfully able to simulate this basics blink of LED experiment. Yes, you have to use the simulation itself, and over there you just have to drag the blocks like I have shown you here. So I can share my screen again. So just a quick recap. What you have to do is you have to go to the LED part, drag this block here, change the pin number to whichever pin you want to choose. Let's say I'm choosing pin number 8. Then for the wait block, we can change the time. Again for the LED, you can change the pin number to same pin number which you have connected here. Make this off so that the cycle continues, and bring the wait block here again. So what this circuit will do is pin number 8 connected to the Arduino, the LED connected to pin number 8 of Arduino, it will just turn on and off for 1 second. Okay, shall we move ahead with the next experiment? Okay. Okay, let's just start with the new one. I'm dumping the code here. So right now what we saw is we saw an output sensor, no, not sensor, output object, which is giving out the reading. But what we want to do now is we want to control the LED like manually. So whatever we did here is we just gave the value and the LED was blinking on and off. But what if suppose you want to just imagine the light in your house, you control it with the button, right? So we will just recreate the experiment. So while doing that, we have to use a logic that if this button is pressed, only then the LED will turn on, right? So we have a logic named here if then. We will just bring out this block, place it inside the loop block. So this will do is if then. So we want a button, right? So we will see in a sensor part, a button option is here. We can click on it. So this is a button setup. So what this will do is, it will give an option of where you want to connect the button. So let's say I want to connect the button to pin number 6. Then we will just go back to button again, and we will bring this block out and place it here. So what this will do is it will check whether the button is pressed or not. And how we are going to make sure that the button is pressed, we have an option here to select. So if I just uncheck this box, you will see a released text appears just above the button. But as soon as I check this box, a hand is here and which is pressing the button, and the text is displayed as pressed. So this will make sure that the button is pressed while during our simulation. Then what we will do, we want an LED. We will just go to the LED. We'll bring out the LED part, the LED block out. You can see the LED is connected to pin number 2, and here also it is connected to pin number 2. Interesting fact here is, as soon as you want to change so suppose the button is connected to pin number 6, and you want to by mistake you click 6 here as well for the LED. So what this will do is it will tell you that your code will not be run because you have two sensors connected to the same pin. So it won't allow, and it will turn all this to gray. But as soon as you change the LED part here to pin number 4, all the sensors will appear on the screen. All the blocks which had turned to gray will appear normally. And then let's say we want the LED to be turned on. We have just made it on, and we want to turn it on for, let's say, how much? 5 seconds. So we'll just turn it on for 5 seconds. So this satisfies the if condition. If button is pressed, the LED will turn on. It will stay on for 5 seconds. But we again have to turn it off as well, right? So we'll just bring this here and we'll make it off. So this will this logic is for when the button is pressed. So what if the button is not pressed? We want the LED to be turned off when the button is not pressed. We'll just bring out the LED block here and make it off. So whenever the button is pressed, it will run through these 3 blocks. It will turn on the LED. It will make it on for 5 seconds, and it will turn it off after that. But when the button is not pressed, it will directly come to this block and make sure the LED doesn't turn off. So we will just see the code for it. As you can see, this code is for the button block, which is connected to pin number 6. This line of code is for the LED, which is connected to pin number 2. mentioned here. Let's just read out what the code is here. So when the digital read is low, so since it is input pull, you will understand the input pull and why it is turned to low in afterwards. This is just for the basic understanding. Just for now, just understand that here we are just pressing the push button, and what this will do is it will turn on the pin number 2, which is connected to the LED. Then it will stay in the same state for 5 seconds, and then it will turn off the LED. Let's just go back to the simulation screen. I will just play the simulation. You can see the LED has turned on for 5 seconds, and then it turns off. You can see the button is pressed, information is coming here, the LED is turned on, and it is turned off. What happens if I do this? If I uncheck the box, if I release the button, if I don't press the button, I wish to see the LED doesn't turn on. So you can see uh, even after I'm playing the simulation, the LED is turned off, because this condition, when the button is pressed, only then the LED turns on. It is not satisfied. So that is the reason it will stay on. But if I do this, if I just check the box for the button pressed, the hand comes here to press the button, the message appears as the button is pressed, and we can play the simulation, and you can see the LED is turned on. It stays on for 5 seconds, it turns off, it again stays on for 5 seconds, since we have loop for 5 times. Yes, can I get information on how many of you are doing the actual simulation using the laptop or system? You can just raise your hand or message in the text. Okay.
I
Okay.
think they can unmute and talk.
Hmm. So any participant who wants to like say something, or you are facing any doubts, you can unmute yourself and raise the question. Just go one by one. So you can raise the hand if you have any doubts, and then we will have a conversation with them. I can see there are more than 38, 40 participants. Uh, I hope that everyone is doing the simulation. Yes, Sujata Bharadwaj, you have anything to say? I can see you have raised your hand. Shonish, I think I read the name right. Yes, Shonish, you have any doubt? Nidhi Gupta, I can see. Yes, Nidhi.
Sir, I had a doubt. Sir, where can we get the hardware material of
नाम
this?
नहीं दे अंदर निकला लड़का.
Sorry. You are saying about the hardware, right?
Yes.
Okay. So I think the teachers will be able to answer this, because in your area you have to find the hardware store, or else there are multiple online platforms which will give you the Arduino. Let's say you can order from Amazon as well. There are companies which gives you the Arduino and deliver it to your address. So you can search it online.
Oh, okay. Thank you very much.
Yes. For the starters, what you can do is you can just find the starter kit. If not, we will be so the in the afterwards, like let's say 20 minutes, I will be shifting it to another platform, and we will be sharing a Google site which will have let's say 10 to 12 experiments, and you can figure out the number of the sensors which you will need to perform those experiments. And if at all you want to buy them, you can just list it out, and when you are placing the order, you can make sure that all the components are there, all the hardware components are there.
Okay, sure. Thank you.
Yes. Have I missed anyone who has raised the hand? So should we move on for the next experiment? Okay. So what we will do is we can have, so there is a, so we have a servo motor here. What we can do is we can click on the servo motor. So right now what I have done is I have refreshed the page. I have deleted all the blocks which we used for the uh, control LED with push button. We will just click on the servo part. We will see there is only one block available. You can drag this block out. You can place it here, and you will see a servo motor has appeared on the simulation screen, and it is connected to pin number 2. We can change that. We can change it to let's say pin number 5, and you will see it is updated here on the screen as well. We can change the degree of rotation here. So servo motor will rotate from 0 to 180 degrees. The normally available ones rotate from 0 to 180 degree. We can just make it 0. Let's say we will just add an LED which will turn on after the servo motor has turned to 50 degrees. So what the logic says is, we will first start with servo motor at 0, then we will turn the servo motor to 50 degrees, and then we will turn on the LED. So this block will serve for the starting of the servo motor. at 0 degrees. We will bring this block here. Let's say we turn it to 25 degrees. So we need some time in between those changes, so that you are able to see the degree of changes on the screen. So we will add a block here, the wait block. Let's say we turn it to 2 seconds. So what this will do is it will start the servo motor at 0 degree, turn it to 25 degrees. It will wait for 2 seconds. Again, we will drag this servo motor block and we will make it 50. So now we want the LED to be turned on. So I will just add the wait block here again, just to make sure the visual representation is available for everyone. And then we will just again add the LED block. So as soon as I add the LED block here, you will see the LED appears on the screen, and we will make it on for, let's say, 2 seconds. 2 seconds again, and then when we will turn it off afterwards. So I'm bringing this block here outside and making it off. So let's say how does the code looks. So you can see, as mentioned previously, in the void setup part, you will have all the sensors or all the components that you are using, the connections with the Arduino. It will be defined here. So as you can see, servo motor has been attached to pin number 5 of Arduino, and the LED, which is connected to pin number 2 of Arduino. So this is our main code in the void loop section. You can see the servo motor at the start is at 0 degrees, then it is turned to 25 degrees. There is a delay of 2 seconds. Then servo motor is rotating to 50 degrees. Then again it has a delay of 2000 milliseconds, which is 2 seconds. Then we are turning on the LED, which is connected to pin number 2, and it will stay on for 2 seconds, and after that it will turn off. So let's say how does the simulation looks like. You just have to focus here. Here on the servo and LED. I will start the simulation. You will see it is rotated to 250, and after that the LED is turned on. We can make sure that it is repeated for n number of times. I will just change the number to 5. So so also you can see for this we have an option of forward and backward. So what this will do is it will take you to the next step of the simulation. So as soon as I click the next step, you will see an yellow border which is highlighted in the block, which is highlighting the block. So this states that at present the simulation is at this step. So when you click the next step again, you will see a wait block is highlighted. Then when you click the next step again, the servo motor which is turning to 50 degrees is highlighted, and also in the simulation part you can see 50 degree servo motor has been shifted. So you have the option of going step by step, forward and backward as well. And at the bottom of the screen you will have all the steps mentioned. So let's say the step 1 is servo motor is rotating to 0 degrees. Then when you click on the next step, servo 5 is rotating to 25 degrees. It is waiting for 2 seconds. Then servo 5 is rotating to 50 degrees. So like this way, even after you are using the block base, an information is given to you on the just below the simulation screen, and on this part code is generated automatically. So you don't have to worry about the writing the code part. So I guess every student is doing right. Uh, we will just have, like, we will give 2 to 3 minutes, then we will shift to another platform, which is also used for Arduino, the simulation platform. But there you will have the control of connecting wires, writing the code. So we use electro blocks as a bridge for you to have the knowledge first, make sure how the circuit connections are done, and then we just take you to the Arduino on cloud platform developed by IIT Bombay. There you will have the access to writing the code and connecting all the sensors to the Arduino. So should we shift to the Arduino Cloud website, or should we wait for 2 minutes more? Okay. So we will shift to the Arduino Cloud website. So this is the home page. I'm in the chat box. I'm sending the link for this platform as well. So you can try it out. You can open the website link on your own computers, and so you have to select Arduino Cloud, and there is a launch button. Just click on it, and here you will have two options: first, explore experiments, and launch editor. So when you click on the explore experiment tab, a new tab will open, and this will take you to the Google sites, where we have given information on experiments coming from blink of LED, control LED with push button, which both the experiment which we did right now using the Electroblocks platform. Then there is a display scrolling text on LCD. So what we have done here is we have documented each part, like which are all the components have been used for this particular experiment, what this component actually means, how does it work. We have given the circuit diagram for you, so that you can replicate the same circuit diagram in the editor, and then you can try it for yourself. We have also given the code here. So those who have learned the how to writing the code, they can write themselves. But if you are struggling for now, you can take the reference from this code. We have also given the explanation, so that you will understand what the line of code means, so that it will make it easier for you to for the next experiment. Oh, okay. So yeah, my bad. I think this screen wasn't shared. So as I mentioned, here we have given list of experiments where all the details have been shared. So we are so suppose in the experiment of display scrolling text on LCD. So you might have seen on the railway station, the railway platforms, a text appears from left to right on the screen. So how does that work? So for that experiment, the simulation part we have given LCD display, which is a required component. How does the LCD work and where it is used? We have given a circuit diagram of it so that you can replicate with the same circuit diagram on your editor. We have given the code, and we have also explained the code here. So what this will do is you will understand what the line of code is, how you can write the code to make the changes according to your own needs. And here we have given a brief output which will show you that for this particular code, this is the expected output which you should be getting from the simulation. Okay. I think Nidhi, you have any doubt?
Sir, I still cannot understand this simulation about the cloud.
I will take you all through it. I'm just right now I'm giving the documentation part. I will just in a minute I will be sharing the screen how you
Oh,
can.
and sir, there is also one student. I think there's some student present in the waiting room. I think he cannot join the meeting. Can you please let
Uh,
him in?
okay. We will take care of it. So as I showed you the experiment part, so here you have to come to the launch editor, click here. So this is the basic UI which you will see when you click on the launch editor option. On the left side, you will see palette where all the sensors and components have been shared. So you will see a register. You can just similar to electroblocks, you can drag and drop the component here. You will see a breadboard coming out. For the controllers, we have Arduino Uno. Likewise, for the output components, we have buzzer, LED, motor, 7-segment display, RGB LED, LCD screen. For the input, we have push button, ultrasonic sensor, which detects the object in the vicinity of the sensor, a PIR sensor, switch, gas sensor, temperature sensor. Likewise, we have battery as well, and we have a motor driver IC which is used when you want to run the DC motor. So let's say we create a similar experiment of blinking an LED. So what this will do is first we have a Arduino, we have a breadboard. We will need an LED which is inside the output palette. We'll drag it outside, and you can see there are two ends for the LED. There are two legs. One is positive. When I hover around it, one is positive and one is negative. So you will have to connect just shown in the electroblocks platform. The positive leg will go to the pin number of Arduino, and the negative leg will go to the ground pin of Arduino. So we will just place it here. We need a resistor as well. You have seen the resistor in the electroblocks circuit as well. when we blink the LED. So we can connect the LED, resistor here. Just we have to make sure that whenever we want anything, any component to be placed on the breadboard, you have to make sure that there are red blocks available when you place it. So suppose if I try to place it here and there are no red blocks, no, the resistor isn't connected to the breadboard. But when the red blocks appear, it makes sure that the component has been placed properly and to the designed spot. Yes. So now we have to connect the positive pin of LED to pin number, say let's 12. So as you can see, we can drag the wire. So for now, I will just, so suppose you want to connect this point to pin number 12. You can just double click on the that particular point and drag your cursor and make connect the wire to pin number 12. So for now, this wire is black. We can also change the wire. When you click on it, you will see a dialog box here. You can change the color of the wire. We can change it to red, and it is changed to red. Now we want the negative pin of LED to be connected to the ground pin of Arduino, which you can do from here. So this is the ground pin as mentioned as it appears on the screen. We can connect to the ground pin. So we'll keep this wire as black. So now here, this is the toolbar where you will have all the options. So you can see on the left hand side, there is option for code. Then there is option for start simulation. Then there are undo redo options. So we'll just write the code for now. So again, in the void setup, we have to mention the component that we are using and which Arduino pin it is connected to. So we will write the code. We have connected the pin to Arduino pin 12. Then we will write the void loop code. So when we want to turn on the LED on, we use high command. Then we will give a delay of, let's say, 1 second. Then we want to turn off the LED. So we will write digital write 12 and then low. And again, we will give a delay of 1 second. So this code, so many of you will not have, since you are starting with a fresh, you will not have access to all the syntax or all the code information. So as I mentioned previously, in the doc, in the explore experiment option, we have given the code. We have also explained what that particular line does to the Arduino code to the actual hardware. So you can take a reference from there. So let's start the simulation here. What we expect is we expect the LED to be turned on. It will turn on for 1 second and then it will turn off. So let's start the simulation. As soon as I press the start simulation button, a window appears here. It will tell you the compilation. It is starting the simulation, compiling the source code, and a message appears in green color. So many of the times when you are actually going to use the hardware, you will see a green message appears. That means the Arduino code is working. That does not necessarily mean your actual hardware is right. It just makes sure that the whatever logic you have used to write the code, all the syntax, that is right. And as you can see, the LED connected to pin number 12 is turning on and turning off. So this green color message makes it tells you that the code has been written right. So let's say I make an error in writing the code. So all those errors can be generally comes with the syntax part. So let's say there is a semicolon in the code and I don't write. So technically this is wrong, but we have to we can take an example of a student writing the code and he or she forgets to put a semicolon at the end of the code, and then we can start the simulation. So you will see a message will appear in the screen, and it will appear in the red color. So it will also tell you which line the problem is. It will tell you that here on the line 11 pin 12 high semicolon is appeared, but here on the line 13 digital write 12 low, an error is here. So what we will do is we will just stop the simulation, make sure that semicolon is added into the code, and then we will start the simulation again. And now you can see a message in green color will appear, and you will see an LED to be blinking for 1 second. Here you can download. So we have given an option for you to download whatever file or whatever experiment you are doing. You can export it as a JSON file, so that suppose you download this file and you add it to your pen drive or your Google account, then you can have an access to it anywhere, wherever you go, and any PC that you use. So we have an option of save project here as well. So it will save temporarily to the cloud. So save temporary option is also here. You can use the zoom in option, zoom out option. We also have an option of auto arrange. So you can see this wire has been aligned properly, but this line, the red color line, is kind of in zigzag way. So what you can do is, so suppose in terms of experiment where there are 10 or 12 wires in the circuit, and you are not sure, you are worried about the aesthetic of it, and you want all the wires to be aligned properly, you can use this option as auto arrange. It will ask you whether you want to continue. Just click on yes, and like you can see the red color wire has also been aligned properly, just as black one. On the right side, you have a dashboard which will take you to this page, and so this is your dashboard. So whatever experiment that you have done will appear here. In the gallery part, we have multiple experiments available for you. So let's say there is we open an experiment of LCD with breadboard. So I will just open it. So you can see there are all the wires of multiple colors have been aligned properly. That has been made has been made sure that with the auto arrange wires option, and we'll just see the code. So you can see the simulation will print, and on cloud will print on the second line. We'll just start the simulation. And you can see simulation on cloud will appear on the LCD screen. So just to get the hang of it, I advise all of you to use, 1 second. Yes. So I advise all of you to use this document. So here, as mentioned earlier, we are given all the details of each component for that particular experiment, and we have shared the code as well. We have shared circuit diagram of where you should be connecting all the sensors, and we have also given the expected output which should appear on the screen. On top of that, so suppose you are getting used to it, you are getting better at it, we have given an assignment part. So when you do a certain experiment, we want you to explore your own mind and you expand your curiosity and just uh, do small changes in the code where the output will change. So just like in Arduino, so we have an experiment here that will just, so basically it is an electronic dice experiment. Whenever you are turning, you must have played a Ludo game on the smartphone. So what that does is it predicts the number. It randomly generates a number from 1 to 6, and this is the same experiment. So you will see there are multiple lines of code for that. Just for the experiment part, what we have done is you can just take the reference from the code, and this is the output. You will see number 2 will appear sometimes, number 1 will appear sometimes. So yeah, so we urge all the students to use that document to perform all the experiments on the Arduino cloud platform. How many of you are doing the Arduino cloud, using the Arduino cloud simulation platform? Can you raise your hand? Okay, Aditya. Nice. Okay. So just give me a second. Yes. So in the I will share the document as well. In the same link that we have provided, you can just find the experiment. I will again share the document link here. So I've given the link for the Google Sites. You can have an access for it. Okay, so what we will do is in we will give you a couple of minutes, and in the meantime, Rajesh sir will take over, and he will just give his idea about the Arduino day, and we will conclude the session then.
Sir, you are mute.
Yeah. Yeah, I think there are a few students who are still doing some experiments on the lab computers. So as you have seen, there are two things that we have tried to demonstrate to you. One was electroblock and one was Arduino on cloud. So there's a difference in both the things. So electroblocks basically does with a block-based programming, where the moment you drag any sensor or a component to the thing, the code is generated automatically. and the circuit is also made automatically. So this basically electroblock is for the very entry level students who are just trying to learn Arduino for the first time. Okay, so they don't know even any small syntax about a code or anything. So we don't encourage that. We don't say that every student should know about the coding part or anything. The coding is a learning part. So very first thing in electroblocks, the moment you drag and drop the component, you see there is some changes in the code. I think Pratik has already explained you about it. The moment you drag any component, you can see the change in the code for the electroblocks. So the same code, whatever you are seeing in the electroblocks, is written in the Arduino on cloud. Now, what is the difference in Arduino on cloud? Here you have to drag and drop the component. You have to wire the component yourself. You have to choose from this wire goes to there. So you have to wire it yourself also. And you have to write the code, and then you have to do the simulation part. So, and in Arduino on cloud, you have to write a C code. Okay. So what is the code which is generated in electroblocks? Here you have to write that thing. Okay. So I'll just share that thing again with you. Hope you can see my window.
Yes, sir.
Yeah, thank you. So as Pratik has already explained you, so there's a blank screen. The moment you try to add any if or then statement or anything like that, that is the changes that you see in the particular code. Okay, I can delete this thing also. So as you can see, I am trying to add a LED here. So automatically the code is generated and all these things. So you can see the code is auto generated. Okay. Now in Arduino on cloud, you have to write the code. So students who are very much new to Arduino or they don't know even a coding or anything, they can always start with electroblocks. Once you have completed with the electroblocks, you can switch to Arduino on cloud. Okay, so Arduino on cloud allows you to for more components to explore with and try to do it. So I request teachers one small thing before we take the session from the students and from your side for Q&A session. I request teachers please try to submit the attendance and the photographs in the feedback form that has been circulated. Okay. So now the forum is open for all the students and teachers. Please feel free to ask the questions. Before that, I just want to tell you, as a FOSSEE can help your school to set up a lab, how we can have the STEM lab in your school, and how we can introduce Arduino and Arduino programming in your school, in your curriculum, so that one of the subject which is now compulsory coming in NEP 2020 as coding and robotics and all this thing, or alternate labs, what we call it as. So that can be introduced in your school using the Arduino programs, open source hardware programs by the FOSSEE. So we'll, as you have seen, the lab can be set up without the actual hardware also. So students can learn in the simulation mode. So what's the output of this thing? Without hardware, you're learning the coding also, you're seeing the simulation and you're seeing the output also. But once you have got a confidence in the simulation and everything is working, definitely you can work on the actual components also. Okay, so now the forum is open for the students and teachers. Please unmute yourself and ask any questions if there are any. Teachers, please have any queries by the students or anybody, please unmute. You can raise the hand so that our person can enable your this thing. So how many students now? I'll ask a few questions now. How many? Yeah, Suraj Sujata Bharadwaj has raised the hand. Sujata Bharadwaj. Yeah, your voice is not coming. Sujata, your voice is not coming actually. Deepak, any issue?
Sujata, can you unmute yourself?
Hello. Please raise the hand so that we can unmute your side.
I have given the permission, they can unmute.
They can unmute. Huh? Okay. Please unmute your mic and speak. Mohit, are you speaking? Mohit Rajput, are you speaking? If you are speaking, please unmute it.
No, sir, I am not speaking.
Okay, I thought yeah. So, teachers, I just want a small feedback from your side. How was the session, and would you like to? Do you have a robotics lab or a coding club in your schools or anything? Yes, Pratibha, you can unmute and talk.
So just a question, will we be submitting any project on the 25th?
Huh? No, no, because for the schools, we have just given the introduction round. And from next year onwards, for the Arduino Day, we are going to tell the students to submit some projects also. So that will be from the I think more than a month time will be given for the students to come do some projects and submit it. So this year we have just for the first 2 days, 23rd and 24th is for schools, where we are going to introduce them about the FOSSEE programs and how open source hardware can be introduced in your curriculum to learn electronics and coding.
Thank you, sir.
So, Pratibha, your students have done some projects or something like that?
No, sir, we haven't prepared any project as of now.
Okay. So So definitely, I'd like to see the projects if they have done it. It's okay, no issue. We'll see the next time. Yeah.
Okay, once I
Yes,
will
sir.
check
Thank
on
you.
this.
Yes. So, teachers, there's one small questions to you. Please fill the feedback form and submit it. And I would like to know from your side about the session in the feedback form. And would you be interested in taking open source hardware and coding clubs in your schools also? We can help you in setting up the things. So any queries, please unmute yourself. The permission has been given to you. You can unmute and speak. So the form has been already shared with you all. I think I'll just share it again. Just hold on. I'll share the form in the link also. Just hold on. The feedback form link is shared in the chat box. You can just have a look at it. Teachers, the feedback form is compulsory, as based on that we will be circulating we'll be giving you the certificates also. Okay, based on the attendance. Any queries? Please unmute yourself and ask the question.
Sir, you are mute.
Sorry, I forgot to share you a small video that we have created for the Arduino day. So what all things can Arduino do? You can just have a look at it. Audio is coming?
No. Just share only that tab. Particular videos which are open. Share that.
Acha. Only that one, yeah?
Yeah.
Now it is coming?
Yes.
Audio is coming now?
Tanish was not an ordinary schoolboy. He was curious about how things worked.
Why does the fan spin so fast?
Deepak, audio is not coming now?
Good question, Tanish.
Huh?
Let's find out together.
Yeah.
At home, his curiosity turned into action. Every broken gadget was a new mystery waiting to be solved. One day, Tanish discovered something amazing: Arduino.
So code can control real things.
With patience and practice, Tanish built his very first robot.
It works! Wow! Where did you buy this robot? I didn't buy it. I made it.
That one sentence changed everything.
Can you teach me? This is called the Blink program. Every journey starts here. Press the button. I did it! The LED turned on!
Step by step, curiosity turned into confidence.
Wow! We're controlling it wirelessly.
Together, they built more than projects, they built skills.
Woo!
Next, drones!
Yeah, drones!
Years passed, but curiosity never faded.
Remember our first blinking LED?
And now, drones for the nation.
The curious minds, one open source tool, a stronger nation.
This robot helps us learn about science.
So there is also a list of few experiments that we have done it, a very small thing. So this is one of the memory game. So one person has to remember the pattern and repeat the pattern. So once you miss the pattern, you have lose the game. So as you can see, there's a small robot with eyes expression also has been done. So all this thing is done using Arduino programming. This is a digital sand clock. So where you can see the sand is coming down digitally. Okay. So it resembles like something is falling below. It's look like a digital sand clock only. You can rotate again and you can see. Okay. So students has to see what goes inside, how it is made, how this drop is coming. Okay. What are the sensors there? You can see this as an output because LEDs are output. But what is the input out here? So you have this another called as a robotic arm, where we can program the robot to do some work. Okay. Now, if it is some same job he has to do, so we can program that thing. Like now here, so it is going to come at some position, lift, pick up an object, and move and put it in the black bin. Okay. So it is putting in the black box or bin, whatever it is. Now this is the work he has to do. Now this is program, so now it is going to do all the things automatically. So this is program and he is able to, the robotic arm is able to do the work. Okay. So this is another game which has been developed where the user is shooting the color, what the light is coming, that light he has to shoot. Okay. So there are multiple levels in it, how students can make it fast, slow, or there is a shooting from that side also. So there are multiple levels in it. So once the student miss this thing, now you can see the things are coming fast. And if the student miss it, all the thing goes red. Okay. So there are different levels also in it can be done. So that's what I'm saying. Arduino is not only a small device where you can create a robot or some device, but a lot of other things that comes in your mind can be done. And definitely we at FOSSEE are always available for you to help you out in creating the projects for your science fairs, and all this thing can be done. Okay. So that's what we always say, bring your ideas to life. Join our FOSSEE open source hardware program. Thank you, teachers and students, for attending the Arduino Day session. I hope you have gained some knowledge about Arduino, and you must be curious to learn more about Arduino. Please join the FOSSEE Arduino program. We'll definitely love to help you and give you the curriculums and all these things so that your school can also start with the Arduino STEM lab in your schools. Thank you very much.